Okay, so right now I want to do a little bit of review of what we know about radicals so far, and then we can move on to the next section. The square root of negative 64 cannot be simplified using real numbers. You're not allowed to have a negative inside of a square root. You are, however, on number 2, allowed to have a negative outside of a square root. That negative just comes on over, and then the square root of 64 is 8. On number 3, we mentioned how you cannot just say the square root undoes the square. Your answer must come out positive. It's not going to be negative 8. The absolute values turn that into a positive 8. Now number 4 has a negative inside the radical, but because it's a cube root, that's okay. We cube root the 27 and we get negative 3. And that's a number you should have memorized, that 3 cubed is 27. Number 5, pretty standard problem. That'll for certainly be on your tests. We're going to have, I don't know, let's go with 6 times 8. 6 breaks into 2 times 3. 8, I'm going to make that 2 times 2 times 2. Now, I have a pair of 2's close by each other. I've got another pair of 2's kind of in a weird way that way. So I have 2 2's coming out, and that comes out as a 4. Leave a little space for my variables. I'm going to have a 3 left inside. I move on to the variables. X to the 5th, I divide that by 2. It goes in 2 times remainder 1. And that tells me I'll have an x squared on the outside and 1x left over on the inside. And then 7 divided by 2 is 3 remainder 1. So I'm going to have y to the 3rd on the outside and a y left over inside the radical. Odds are that's your answer because there will be a disclaimer saying that variables represent positive values. But if that disclaimer is not there, you would want to put absolute values around the y to the 3rd because that is the odd power coming out of an even indiced radical. For number 6, we have an 11th root. So we're going to take our 56 divided by 11. That goes in 5 times to make 55 with a remainder of 1. And then we're going to take our 90, divide that by 11. We know 11 times 8 is 88, so we're going to have a remainder of 2. So we're going to have 5 x's coming out, that's x to the 5th. We're going to have 8 y's, that's y to the 8th coming out. And then inside the 11th root, I'm not going to forget my index on my answer, I'm going to have 1 x left over and 2 y's left over. Now in this problem, we do not even consider using absolute values on that x to the 5th because this is an odd indiced radical and we do not use absolute values unless it is an even indiced radical. On this last problem of this video, we're going to use the Pythagorean theorem to solve for x. We're going to have 3 squared plus x squared equals 8 squared. That's the sum of the squares of the lengths of the legs of this right triangle equals the sum, or sorry, not the sum, but the square of the hypotenuse. This gives us 9 plus x squared equals 64. When we subtract 9 on both sides, we get 55. And then x, when we square root both sides, is going to be root 55. Technically plus or minus when we're solving this equation, but because we're dealing with the side of a triangle, which must be positive, we're just going to leave this as positive root 55.